I don't know if apology is the right term, but the term GWT is a total accident. It just stems from the fact that W is a 3-syllable letter that I think it was actually Larry Page who first said, shouldn't we just call this thing GWT? Because it's a lot easier to pronounce. So as weird as it sounds and ugly as it is, it certainly does reduce the number of syllables that one has to utter in a normal day. So anyway, that's kind of the genesis of that. So as Greg was saying, I want to talk a little bit today about performance. You're going to hear a lot, you may have already heard a lot about how GWT, and I'm going to keep saying that, about how GWT abstracts you from the browser. You don't have to worry about the web browser because we've created all these glorious levels of abstraction that will keep you from having to worry about the details of the web browser. It's a nice story, and it is even true sometimes. The reality, though, is that it's still a web browser. So I don't think anybody would be surprised by the statement that no one ever really expected web browsers to be driven this far. They weren't meant to do the things that we are making them do. This was true before GWT, and it certainly remains true now. We're seeing great optimizations in various web browsers, not least of which WebKit. If anyone has not checked out Safari 3, it is probably the best browser I've ever used. It is significantly more performant than any other web browser by a wide margin. So we're seeing a lot of progress, but the fact of the matter is it's still dirt slow. I mean, JavaScript, not surprisingly, is not a terribly fast language. Not saying that there aren't, in theory, some ways to make it significantly faster, but as a purely pragmatic matter, it isn't. It is, depending on what you're doing, JavaScript code tends to be on the order of several hundred times slower than native code. Depends on what you're doing, but essentially that is an unavoidable consequence of the way it is implemented right now. It might get better one day, but that's the reality we're going to be stuck with for a very long time. You guys may recognize the computer on the right, which is about the kind of performance I expect out of the average web browser. For anyone not familiar with that, that's my old Commodore 64 from about 1985. That's about the right order of magnitude. I mean, I can do things on a Commodore 64, an old 8-bit micro, that I cannot do in a web browser. So these are just things that we have to accept. That is the reality. Really, sorry, there we are. So there's the JavaScript language, and then there's manipulating the DOM, the object model on which everything in a web browser is essentially built, is even slower than the language. So this one example here, I'm going to add an item to a list box. Arguably a pretty trivial operation. Takes on this MacBook Pro, which is a dual-core 2-point-something gigahertz machine, about 200 microseconds. Tested it this morning. That's 460,000 clock cycles. Now, we can argue about how many instructions that is and whether it involves pipeline installs, blah, 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 but that is a huge order of magnitude. That is a massive amount of code to be running to add an item to a list box. Again, I have very high hopes that that will get faster. Safari, WebKit, for example, already is making it faster, but it's still really, really, really slow. We do have one out in all of this, though. It doesn't get you out of jail completely free, but it does make your life certainly a lot easier under some circumstances. And this is to a certain extent, a unifying concept that I'm going to try and keep returning to in this talk. The only thing that matters is that it doesn't seem slow to your users. So if it is complete, whatever it is that you're doing with the web browser, if it is a complete abuse of the web browser's capabilities and it's taking 1,000 times longer than it ought to, it's okay if your users aren't waiting. When my mom goes to use, Google Maps, as long as she drags the map and it drags, and she clicks something and something comes up within, say, 100 milliseconds or so, she's pretty happy. She doesn't know that her CPU is being taxed and generating a lot of heat under the desk. She doesn't really care as long as it works. So the fact that simple fact allows us to get away with a lot. As long as you don't sort of anger the usability gods with respect to how long you take for any particular user action, then all will be well. So there are two aspects that I want to cover, two broad aspects. There's how fast does my app start, and there's how fast does it run once it does start. I think it's worth treating these separately because they tend to be influenced by they're related but largely different sets of constraints and considerations. And they're both very important but for different reasons. So runtime performance, I think no one would argue that that's not important. It's pretty obvious that when your app is running that it responds quickly and smoothly and fluidly and you'll be able to do what you need to in a reasonable amount of time. Startup time is something that, depending on where you're coming from, depending on who your users are, what your use cases are, and what your expectations are, you either do or don't care about. What I want to impress upon everyone here is that you do care about it, whether you know about it or not. So one thing I learned from someone working on a very highly used application at Google is that they found that the abandonment rate, that is the rate at which people leave a page after going to it as a function of how long it takes to load, is nonlinear in the load time. And unfortunately, that's not sublinear, that is superlinear. So they found that if the app took a second to load, they lost X percent of users. I'll make up a number, call it 40%. If it took half a second to load, they lost 30%. But if it took a quarter second to load, they lost 5%, something along those lines. So that is, the longer it takes to load, the more users you're going to lose. And that is really, really important. I think Bruce said the other day, when you're on the web, your competition is always a click away. Depending on what you're doing, if it's very consumer focused, that's absolutely true. If it's less consumer focused, it's still partially true, because you don't have this world anymore where people have downloaded your application and are going to run it, and if it takes a minute to start, they're going to sit there for that minute because they're already heavily invested. Most users on most applications, even business and enterprise applications, if they click on the link, they follow the link, click start, whatever it is they do to get into the application, their attention wanders very, very rapidly. And I cannot impress upon you enough the importance of that, because you lose users and you lose them fast if your app is slow to start. Little quote that I borrowed from one of my cohort's talks. Don't always agree with Jakob Nielsen, but he has a lot of good things to say. And he's been saying this for ages, and he's been right the whole time. Slow makes people very unhappy. So what affects this? We often hear code size. People make the immediate assumption, and this does matter, they make the immediate assumption that my app's 300K, if I could only get it down to 150, it would start up really fast. The numbers vary with individuals and different applications and so forth, but essentially you hear that over and over again. The reality is it's not always true. If you have a 2 megabyte JavaScript application, it will load slowly. Most of that will be download time. But even once it's cached, that can take a little bit of time to start. But the JavaScript parser is not as slow as you think. So once that code is cached, it tends to load pretty quickly, but there's a lot of other things that affect startup time. So the normal process looks like this. So we've all heard this, but I'm going to reiterate it I'm just going to reiterate it. So is it cached? I hit a website, let's say, simplest possible case, HTML, one reference JavaScript file. Everything else happens as a result of the JavaScript loading. So first question, you're going to get the HTML page down. Let's assume that's not cached. First question, is it cached? Okay, if not, I'm going to download the script. Now, if it's a megabyte script and it's over dial-up, that's going to take a while, but it only happens once. Now I'm going to parse the script. We have to answer the question, how long does the script take to parse? And is code size actually a big factor here? And then you've got to execute that script, obviously. Now, one thing is your script size, the most important thing about script size is that it is how it affects download time. So if a script is, again, to use a random example, is a megabyte, that's going to take a while to download. But it's only the actual size of that request that matters. So you should always, always, always gzip your scripts. So I know, I'm not sure if it's right now, I think it's a little later, Bob Vaughter and Rob Jellinghouse are doing a talk on deployment. If you're interested in deploying apps, you should definitely, if you are actually going to be deploying apps, you should definitely see this. There are a lot of little simple pitfalls that can cause you to get either bad cache performance or like forgetting to gzip, for example, is a huge deal. GWT goes to some great lengths to make sure that you can always gzip your scripts. There are bugs that make this awkward on IE under some circumstances, but we make sure that this will never fail. So if you're asking yourself, can I safely gzip it for all my customers, the answer is yes. Typically you're seeing somewhere between a 3-to-1 and a 5-to-1 compression ratio on JavaScript. Our JavaScript doesn't compress quite as much as some because it doesn't include as much redundant crap, but it still compresses very well. 4-to-1 on average, let's say, in my experience. So we've eliminated a lot of the network bandwidth problem. Now we have parse time. Turns out one of my cohorts ran a test where he wrote a Python script to generate extraordinarily large amounts of JavaScript, megabytes and megabytes and megabytes. And he had a difficult time actually measuring how long it took to parse, because on any modern machine, parsing JavaScript is basically free. The cost is almost immeasurably small. So that's not a big issue. But then you get to execution. That's where really most of your pitfalls lie. I mean, assuming you've got it cached, assuming you've got your network bandwidth problem solved with gzipping and so forth, it's once that script starts executing that you start running into problems. Or you can. Hopefully you won't, but probably you will, and hopefully we can figure out ways around those. So, in that hypothetical example I just gave, let's say one HTML page, one cached script. Well, one non-cached script, let's say. That's 2 HTTP requests. HTTP requests will eat you alive. The cost of making one is difficult to overstate how slow it is. I don't have numbers off the top of my head, but it's almost irrelevant. It's so slow comparison to almost anything else you can do, that anything you can do to avoid making HTTP requests will save you lots and lots of time. So far we've made 2, let's say, in the uncached case, in this hypothetical example. But there's a bunch of other stuff that you make requests to get. So we've got style sheets, which, having one is a pretty good benchmark for style sheets, but people often stack up 4, 5, or 6 of them. I've seen some apps from very large companies that produce HTML pages with like 5 and 10 CSS files referenced. That's killing their startup performance. Images, not surprisingly, especially if you have things like toolbars, lots of rounded corners, lots of little images can kill you as well. Your application can take forever to finish loading because it's constantly fetch. We have some ways around that. External scripts. So obviously if you're using GWT to produce an application, in the purest sense, you're going to have one script. Technically 2 with the selection script, but you can inline that if you need to. But having external scripts, let's say, and there are perfectly good wrappers for things like Scriptaculous, for example, but loading a typical Scriptaculous-based page is going to load at least 2, at a bare minimum, extra JavaScript files. That's a big deal. If you can do something to get around that, then you're going to come out ahead. And then finally, remote procedure calls, whatever form that takes. If you're making JSON requests to a server, if you're using GWT RPC, whatever, those matter, and you want to minimize those. Certainly on startup, especially. So what can we do about all this? Any place where you have multiple of something, if you can turn it into one of that same thing, you're going to come out ahead, right? So if I can turn 3 scripts into one, that's good. Same thing, CSS files, that turns out to be pretty easy because you can always concatenate CSS files. That always semantically does what you want it to. Same thing's true with scripts. At the very least, if you're using external scripts, non-GWT scripts, run a minifier on it, that is, get rid of all the white space and stuff like that, that's a little bit helpful. But concatenate them, that's a huge deal. It's a poor man's JavaScript compiler. But it's very effective because if you get rid of those requests, then that's very large, expensive operations that are going away. Images are a little trickier. So let's say I've got, a toolbar. And anyone who's written old Win32 code or MFC code remembers that you used to specify toolbar images in one long strip. Well, that strip that is a single image. It's fast to load. It was the same reason they did it on Windows back in the old days. And it's the same reason you want to do the same thing in the browser. Unfortunately, the tricks to actually get those to display properly are kind of obtuse, which is why in GWT I would suggest you use image bundles. If you haven't seen that, and it was new as of 1.4, it's a great way to automatically spritify your images. People use the term sprite fairly often to describe this process. I think of them as image strips, but that can get rid of, and I've seen commonly in applications with like 60 or 70 little images built into them. If it's complex application, that's not really uncommon at all. That makes a huge difference in your startup time. And actually back to perception, it really makes a huge difference in the perceived startup time, even above and beyond the measurable difference. Because anyone ever seen an application, a web app, where you load the page and 5 minutes later it finally stops jiggling around as all the images load? If you pre-bundle all of your images, you get rid of that whole jiggling process because the compiler then knows, if you look at the image bundle documentation, this will make more sense, but in broad terms, the compiler knows how big the images are at compile time, so it shoots that directly into your code, so when you go to create one, it already knows and your layout is already fixed. A little tiny image coming in later doesn't look anywhere near as bad as the entire page shifting 4 pixels to the right. That, again, back to perception, that makes a huge difference. One other thing, a little more subtle, but can be very useful. So let's say I'm writing application, let's say I'm writing a mail app. And the first thing I need to do, basically the application can't display very much interesting UI until I've actually got data. But in sort of the most pure way you would approach this, you say, I'm going to get my HTML page, my script, and the script's going to request data from the server. Well, that's great, but it would be a whole lot better if you already had that data. It's certainly possible. So another trick that I've seen people use is simply to pre-encode enough data, maybe your basic settings or your contact list or whatever's appropriate, in the outer HTML page, if it's a fairly small chunk of data, and then just loading that up on startup, then firing off any other requests you need to display your UI. Again, it's a perception thing. But that makes both a difference in perception and really a measurable difference because that extra request was very expensive. So those are just kind of all, again, very broadly different ways of approaching getting rid of HTTP requests. The main takeaway I want to leave with this though is get rid of those requests. It makes all the difference in the world in your startup time. One small subtle thing I want to point out as well. This really applies more to JavaScript apps in general. In GWT, we do some work to make sure you don't have to worry about it. But anyone familiar with writing JavaScript, you have body on load. Typically, is where you do sort of startup code. The nasty little secret of body on load is that it only fires once all of your images, iframes, and CSS files and other resources have already loaded. So if you have statically specified images or an iframe or anything like that, it can take many seconds before that actually fires. One example, you can see this in a lot of pages where there's an obvious text box that is the first thing you're going to want to focus on the page. And when the page loads, the text box is sitting there and it's not focused. You see some images load in, and finally the text box focuses. They just did a body on load, focus this initial text box. That is, when you're just focusing a text box in a static page, it's irritating, but it's not the end of the world. If you're waiting 2 and 3 seconds to even start executing your script, that's really bad. GWT will, if anyone's familiar with entry point on module load call, where you really start all of your code, that is guaranteed to be fired before any external image, or at least not until, It's guaranteed to not fire after all of your external images and so forth. So just so you know that's the case, that is a useful, and it can be a pretty significant optimization if you have any static resources in the outer page. And then one last thing I want to say about that is, I'm referencing this thing, Charles. If anyone's seen this, it's a debug logging HTTP proxy. There are probably 10 of them out there, but use a proxy to measure your request layout, if you will. Figure out what you're requesting, figure out how long it's taking, figure out whether requests are being made in parallel or serials, and there are certain things you can do to sort of anger the browser gods and cause them to serialize a bunch of your HTTP requests. You can be taking twice as long as you think to actually load your application. Usually it becomes starkly obvious when you actually run it through a proxy. Again, I reference Charles because it's cross-browser and I love it, but there are many of them. One word of warning, by the way, do not use Firebug for debugging your network. Not now anyway, maybe in the future. It doesn't log any local requests, which can be a pain when you're trying to debug. But more importantly, it is just simply often wrong about timing information. That has been my experience. If that is fixed already and I don't know it, please let me know. But to my knowledge, I've never had good results with Firebug's network debugging, and it's actually led me down a rat hole fairly often where I've tried to chase something that doesn't exist. So be careful with that. Okay, so enough about startup. One thing I do want to say as well, if anybody has any questions about anything I'm saying, I know I'm moving fairly fast. I've got a lot of material I want to cover. Feel free to stop me at any point. That's not a problem at all. So, as I said before, we are actually concerned about runtime performance. That is also very important. So let's say we've got the startup problem solved, but if my application is sluggish once I get it loaded, and there are a lot of counterexamples of Ajax applications that are slower than they would have been if they had just written them in straight up HTML 3.2 on a CGI server. That is very easy to do if you're not careful. So, and there are a lot of things that really influence whether an application feels snappy. The number one is simply working, as I was mentioning before, working with the DOM is very, very slow, right? That involves creating elements, setting text on elements, setting styles, changing colors, whatever, the things that you do to get your UI rendered, they're almost all slow. So anything you don't do is going to be a whole lot faster than something you do, right? It's kind of obvious, but it leads to one simple pattern that will get you out of a lot of trouble. When I go to create, if I don't need a particular piece of the user interface yet, then I should absolutely not create it. So, as I was saying before, if you don't execute code, it can't take time. If I have a crude example would be if I have a settings page, it might be tempting to pre-create that so that the settings page itself comes up more quickly when they do click on the settings button, but I don't actually need it when I start up, and it's a whole lot worse generally to front load a lot of work when that work's going to be expensive and you're already piggybacking on the relatively slow loading process. I mean, loading a web app is still slower than we'd all like it to be. We don't want to do anything to make that any slower than it already is. So basically the sort of the mantra of lazy UI creation is, and this applies to other things as well, but UI creation is so slow that I tend to focus on this one aspect. Amortize your work over time. If your application is consistently a little tiny bit slow, that's a whole lot better than having it be really fast sometimes and really slow other times. So again, if your startup is really slow and then your application is really snappy, that's still going to leave pretty much a bad taste in anyone's mouth that's using it. So the good news about lazy UI creation is that using simple Java constructs, it's pretty easy to abstract this process out so that your application code doesn't get really messy. So if I'm writing sort of a top-level controller, it doesn't need to know whether or not a particular piece of the UI is visible. If it needs to hook up, let's say it needs to hook up the model early on, or it needs to instantiate some part of the UI, there's a lot of stuff inside it or hidden tabs or whatever that it doesn't really need yet. The higher level application code doesn't need to know about that. You can bury that inside composites. So this is general advice. This would work for a Swing app or an SWT app as well as it would for a GWT app. This is a kind of a contrived example, but I've got some kind of data view, and I'm not going to have the data until later, and it's not going to display anything when it doesn't have the data. Maybe it's hidden, maybe it just doesn't matter yet, maybe it displays a loading page by default or loading text. But when the data is available, just instantiate the heavy part later. And then later on, if that happens subsequent times, you obviously just don't recreate it. The corollary to create things lazily is don't recreate them if you don't have to. So if you hide something and reshow it again, just hang on to a reference to it. Don't recreate that dialog box. Because if you can make it faster on subsequent runs, that's even better. That also has a tendency to not thrash the garbage collector in the browser also, which is very convenient, especially on IE, which has probably the worst garbage collector ever written. If you go, you're welcome. No, that's, I didn't actually realize this until recently. I think it was, I've forgotten who it was, maybe it was somebody working on Gmail, who basically was trying to track down some really bad performance issues on IE. It wasn't that it was always bad, it was just that it was surprisingly bad at really inopportune moments. And, but to my knowledge, no one, before this, no one had ever really tracked it down. I mean, maybe somebody at Microsoft did at some point and then said, screw it, we'll worry about it later. Apparently they did. But not leaning on IE's memory allocator too much is a good thing. And since, with the exception of some very rare use cases, probably about 70% of your users will be on IE, you do need to worry about this. And you and I, all of us Mac users out there, which I detect in a surprisingly large number, we need to actually have a Windows box around for this purpose. It's really worth it. So, like I said, create lazily. Sorry? Yeah, but most Linux developers have machines they can at least dual boot to Windows. Actually, I guess we can now with the Macs, can't we? I just don't feel like it, but I keep a Windows box on my desk that I try to just keep from putting anything important on it. That is true, although it's kind of bad for performance measurement. I guess in relative terms it's useful, but at any rate, just again to recap, create lazily, reuse whenever you can. You will be very, very happy for several reasons. Another subtle thing we discovered actually fairly recently. So several of the widgets in GWT, like the tree, for example, is one particularly egregious case, does far too much direct DOM manipulation. That is something I'm working on personally right now. There are a few cases where we do a lot of create element, set property, or set attribute, et cetera, in a big linear chunk of code. It turns out that in the bizarro world of JavaScript in the browser, invoking the tag soup parser that's built into the browser is probably an order of magnitude faster than doing a bunch of DOM manipulation. To me, it was completely counterintuitive. I mean, if I could run C code or invoke a C parser, which would I use? Well, I'd probably just run the code. Well, this is completely backwards. If you use, imagine we're just in JavaScript, div.setAttribute, div.enter HTML equals some big chunk of HTML, and then just dig through it and dig out a few pieces I need to manipulate. That's just a whole lot faster than creating those elements manually and add child or pin child, append child, append child, et cetera. It's beyond me why that's the case, but it is. This is one case. The HTML panel, for those of you actually already using the libraries, is the redheaded stepchild of GWT. No one ever even knows about it or quite what it's for. It actually was created for this purpose. It's not the only way you can do it, but it's a really convenient way. So if I've got a bunch of boilerplate HTML, and which we often do, I mean, you can construct a whole lot of static things just by writing HTML. It's very, very efficient to set up that way. And oftentimes, all I really want to do is add a few dynamic pieces inside it. That's a pretty efficient way to do it. I make myself a new HTML panel, and then the semantics of it are I can add a widget to any part inside it by ID. There's a little convenience ID allocator, because IDs have to be unique. But for certain things, I've tended to use it for things like big complex chunks of HTML and headers, things like that. That is a really convenient way to avoid a lot of overhead. I'll talk more about this tomorrow in a talk on sort of widget gory details of building your own widgets. But you can use the same trick inside by creating, say, one div, and then if you've got a bunch of stuff that you need to put in that you need to put inside that div, that most of it's static, then you can just use set attribute inner HTML and be done with it. I think there's a direct set inner HTML call. That you'll be very happy about your performance if you do that. Mm-hmm.
Better performance of inner HTML to browsers?
Absolutely, in my experience. I am shocked by that as well, to be honest, but it seems to be the case. Another thing, and I think we've done a fairly good job of leading by example on this, but I want to reiterate it. Absolutely use style sheets. It's conceptually the right thing to do because it's always a good thing if your apps are basically stylable by default, but it's also the right thing to do from a performance standpoint. The top line there will always be significantly faster than the bottom one for reasons that I think are fairly obvious, with the possible exception of a couple of corner cases like CSS expressions in IE, which you shouldn't be using anyway unless you absolutely have to. That's going to be less code, and all of the application of the various style attributes will be run in native code for you through a relatively efficient code path. Whereas if I set all this stuff manually, which I've seen code that does this, and it invariably gets fat and slow pretty quickly. It's just less code. Always a good thing.
Is there a good way to deal with the static image versus CSS?
Not as much as I'd like. I would absolutely love it if we could get internal clipping regions on CSS backgrounds. They just never thought about doing that. Scott? Oh, sorry. Yeah, I forget about the whole recording and microphone thing. The question is basically, is there any way to use, correct me if I'm wrong here, use CSS backgrounds essentially from an image bundle? Because what you'd like is not have a bunch of CSS background image requests. Alex? That was, yes. So I don't remember the details exactly, but if you can track down Bob Vaughter, when is he talking? Anyone? Oh, hey, Bob. You're right there. That's right. You helped me set up my machine. Bob can tell you all about what is it called now? Immutable resource bundles. So Bob's working on a solution to that will, and correct me if I'm wrong again, that will deal with that problem in a way that will be the most optimal that it can possibly be on different browsers. So you tend to have lots of CSS backgrounds, with a few exceptions, tend to be lots of little tiny images that fit remarkably well in data URLs. So it's weird to have an image base64 encoded in your CSS, but it is actually remarkably effective. Bob's worked on a really cool way to optimize that and automate that process. That's up on the incubator now, isn't it?
Yeah, 1.6.
It's going in 1.6. That's what I hear. That was a commitment, I think, you just made. But yeah, it's already exact. I mean, you used it in the iPhone feed demo, right? Yeah. For anyone who's not seen the GWT feed reader demo on the iPhone, it's pretty cool, and it uses this trick because. Oh, and this is another point. I don't think I remembered to make it anywhere in my slides, but it'll color everything else to a certain extent. If you think HTTP requests are slow now, wait till you get an iPhone if you don't already have one. The Edge network has its connection setup latency, is what it appears to be anyway, that is just excruciatingly slow. So getting rid of HTTP requests there, instead of dropping a couple hundred milliseconds, you're dropping like a couple of seconds. That's huge. So style sheets are good. Another subtle point, we all, I think, know that the browser is single-threaded. It is and probably always will be. And I think that's actually a good thing. I mean, if you think back to, for the most part, if you think back to like Swing or what have you, SWT, pretty much UI frameworks, UI toolkits tend to have thread affinity. So you pretty much end up with a single-threaded UI. The problem with JavaScript is it doesn't provide an easy way to do background work. Things like HTTP requests are done automatically in the background, but it's very specialized. There's no way to say, I'm in the middle of a long-running task, please pump the event loop. That's what I would have done in old Win32 code. It's very effective. Give the system a chance to breathe. Well, the closest thing you can get in the browser is, in GWT we call this a deferred command. Under the hood, the implementation is sort of a timer with a 0 millisecond timeout. But essentially, what you want to be able to say, if I am going to do a lot of work in one pass, what I really want to do is break that up into multiple passes. And let's say, for example, I'm taking an RPC response with a very large chunk of data in it, and I'm populating that into a table, which is not the fastest thing in the world. What I really like to be able to do is give the browser a chance to breathe, and therefore the user a chance to actually interact with the UI every so often. Because remember, when you block the UI thread in the browser, you block the whole thing. That includes Chrome, menus, URL bar, back button, and in Firefox, other tabs. Firefox, unfortunately, has a single-threaded UI model for the entire freaking application. Yeah, don't get me started on that, but that's really, really, really bad. That's like the worst thing you could possibly do from a usability standpoint, because that's the kind of thing that would make my mom go, my system got frozen up, I'm never going back there. So be careful about that. If you use a deferred command, you say, okay, I'm going to process 10 rows, and then I'm going to fire off a deferred command to call back and do the next 10 rows, and just keep doing that until it's done. Essentially running it in a timer. Bob, Toby, one of you guys, what is the other thing called that we built on top of that? Is it deferred? Incremental command. So deferred command is the sort of the manual version. Incremental command will do this in a more robust way that gives a reasonable amount of sort of breathing time to every phase of the operation.
Operating system function.
It is a lot like that, actually. It smells a lot like that. Most of the time, I would advise you to avoid getting into a situation where this will be necessary, but there are cases where it will crop up. Like I said, large amounts of data. Personally, I prefer small amounts of data that page, let's say. But if you do get yourself into the situation and it is actually a use case that you really want to support, then this is a way to get out of that problem without seriously re-architecting your app. So, speaking of fetching data, I want to talk a little bit about fetching data. So again, I keep repeating myself, I sound like a broken record, but minimize your HTTP requests, right? So every RPC you make, if you use GWT RPC, if you use JSON, XML, God forbid SOAP, whatever, you want to minimize the number of requests that you make. Well, that's great, but when you need data, you still have to make a request. Two things you can do to minimize requests when you're getting data. One is simply to cache it so you don't have to ask again. So if I'm in a mail app and I've got any like page data table, let's say, if I can, you have to work out the caching semantics, that's an application specific thing, but if I can cache each page, at least for some period of time, then paging back and forth through a paged grid is very, very fast because you're not making any extra requests. That makes a big difference. The app can become very, very snappy. The other thing's a little more subtle, which is if you could be making, well, how do I want to say this? If you would normally break things up semantically, like I'm going to ask for settings by a call or remote call called get settings, seems reasonable. I'm going to ask for contacts. This is, imagine I'm in a mail app again, with get contacts. And I'm going to log in separately. So my startup process looks like I'm going to log in, get an authorization token, let's say. Then I'm going to ask for the settings. Then I'm going to ask for the contacts. Well, that's great, but I just made 3 HTTP requests. Conceptually, this makes sense. It seems nice and broken up, but it's slow, and it's guaranteed to be slow because those requests, they are round trips. They are invariably going to take a fair amount of time. So instead, and this is one of the reasons I advocate using GWT RPC, even if you have an existing server that produces JSON or what have you, the ability to refactor your client-server communications it clearly has implications for team development and sort of ease of prototyping and so forth and so on, but it actually has performance implications because you can do the right thing and not have to go and update your XML parser or change your server code to produce slightly different output. So what I really want to do in this case is I'm going to say there's one call that I can make to the server, and the server knows, that's assuming that the server and the client are designed to work together, which is another practice I think is very important. The server knows that I'm about to ask for the settings in contact, so why not just go ahead and send it down? Well, I just took the exact same interface, and I say, log in, just pass a login result object back. I refactor those other results back into the login result, and that all comes down as one blob. If I decide, let's say, for example, that I don't need contacts later, I can just pull that out, or I need to break up some piece of it. You know, any amount of refactor I need to do to that is really straightforward. All I have to do is refactor the one piece of code, or there's a couple of pieces of code that serve as the sort of the source of truth for the communication protocol, and it just works, right? The generator is going to run in the background. All of your compression, or your encoding and decoding code for the RPC format is invisible to you, and it's just happening. This again makes a very, very large difference. In really complex apps, so apps with a lot of sort of interoperating pieces that are somewhat independent, Mail app actually, again, provides a pretty good example where you've got sort of contacts, maybe you've got a chat built into it, you're asking for messages, you're pinging for new messages, maybe you're asking for message bodies, et cetera, et cetera. Like all these things are happening somewhat independently. I've seen people go so far as to essentially have an abstracted request response mechanism where you just send, you have one RPC method and you send an array of requests up, an array of responses back, and then everything that extends request or response can just be tacked onto that bus. You're treating it sort of as a bus back and forth. You don't necessarily want to start there, but for some applications with enough complexity, that becomes a pretty good way to deal with that problem. Then you never make more than one RPC request for any particular user action. You always end up making exactly one. And that's a really, really effective way to speed up your app. So, well, my spacebar will work. Yeah, there we are. So I'm going to shift gears a little bit, talk about compiler optimizations. I'm not sure if that's technically true. I don't know if Grace Hopper's original compiler is actually optimized, but I assumed that because 1949 sounded like a really long time ago. And I wanted to make the point that with GWT, we're not really doing anything new. We're taking really old stuff and that people seem to have in many cases forgotten and reusing it. So having a compiler, I'm sorry, I'm gonna get on a soapbox a little bit here. Having a compiler for your source code that generates output code that is not meant to be read by humans is a good thing. It's been a good thing for a very long time. You know, when Grace Hopper wrote whatever her language was for the first compiler, it was a very good thing that people weren't necessarily reading the machine code anymore. They weren't working directly in the machine code. A level of abstraction that does not impose a cost on your users is good. That is, well, I don't know if I can say that's the primary motivation behind GWT, but it's definitely one of the top 2 or 3. And another thing that reminds me of actually is that so I was watching a talk at OSCON, a very good talk, a guy named Joseph Smar, works at Plaxo. Great application, written through Herculean efforts of JavaScript hackery. He had a great talk on Ajax performance. But one of the things he said really struck me, and it made me feel very uncomfortable. It was the simple fact that he said, in giving advice on how you should write your JavaScript, okay, you remember all those things they taught you in school about abstracting and creating getters and setters and so forth and so on? Forget it. You can't afford it. JavaScript can't afford it. It's too expensive. That's just, I mean, where he is under the constraints under which he was operating, he's correct. That is an accurate statement. This is why we have a compiler, right? You should be able to write in the abstractions you need to use, and we should be able to optimize them out. That is often true. Obviously, there are some cases you want to avoid. There are certain things that are particularly dynamic that a compiler cannot realistically optimize. But it's important to know that the compiler will optimize so that you write the right code so that you don't find yourself with an unmaintainable mess and then focusing on really small scale optimizations to try and get the speed that you've lost because your architecture is broken. Start with a good architecture. Feel free to do so, and I think you'll end up in a lot better place because we can do some really, really cool things to your code. I say we, I'm really referring to Scott over here because he's the one who does all the hard work. Bob's done a fair amount of these as well recently. So, let me use a really simple example. One of the things this same talk referred to was saying if you need abstractions like widgets, you're probably going down the wrong road because it's too expensive to be accessing all the DOM elements through a widget abstraction. Well, I think you should be able to. I just don't think your users should pay for it. So imagine this simple class here. We've got a application that creates a button. Not a very interesting application, but it'll serve. Now I should be able to call b.setText. Now that's not something that exists in the browser, right? I've got a button B, call setText on it, pass it in, button gets a caption. Great. In button, the setText call looks like setInnerText on the element, and you pass in the text. Okay. Now the actual implementation of that setInnerText is abstracted out across browsers. It goes through one more bridge method. There's actually several levels of abstraction going on here. And there's two things I want to show. One is that we can mostly get rid of, not entirely, but mostly get rid of the levels of abstraction here through inlining and so forth. And two, and this is a point that I know Bruce has been trying to make very loudly in a few of his talks, and it's a very important and subtle point that I can't go into great detail on this. I suspect that if you go to Ray Cromwell's talk on deferred binding, he'll go into excruciating detail, very, very interesting stuff on how this happens. But we will generate typically the best code for the particular browser on which you're operating. So InnerText is an interesting case. So IE has an element.InnerText property. You set it, and it wipes out whatever DOM nodes are in there, creates a text node, throws it in there, and it basically does what you would expect. I think Firefox has text content content text. That's the standard DOM version, right? It is okay. So it's not exactly. It's not supported by IE. Right. So the right approach for setting the inner text on something differs across browsers. And I think there's one browser, maybe it's Opera, I forget which, where you actually have to do the DOM manipulation. You have to go and delete all the elements and so forth. So there's 3 full cases you have to handle here. And a typical sort of JavaScript library will have those all written out dynamically. So I say, when I write function, set inner text, takes an element, a text, take element and a string. I will typically write, if inner text supported, however that works, set inner text. If text content supported, set text content. Else, fall back to this nasty chunk of DOM manipulation. It's a big function, and more importantly, all those extra checks get very expensive, especially in a leaf function like this. So this simple Java source actually I'm going to go to IE first. On IE turns into this. So tie them back together. That bottom button b equals new button, b.setText becomes, okay, new button, this is generated JavaScript. The $signs are just an ugly artifact of generated JavaScript. b.element.InnerText equals the string. The or is a guard against null, which will crash some browsers. That's what it ought to look like. That's the code you would have written by hand with no abstractions, more or less. Interestingly, that actually is mislabeled. I think that should be Opera. I have to test this to be sure. But there is a case where instead it has to turn around and call a global function to set that because the global function is relatively large and can't be efficiently inlined. But it does the most efficient thing you could have done on that browser. That is a huge deal in practice. We ran some tests not long ago, compared to sort of the standard canonical set inner text implementation that we found in one JavaScript library to what you get if you just optimize all that out and you do the most efficient thing. It was between 5 and 40% faster. The 5, I think, was WebKit, and the 40% was IE. So 40% faster on a very common leaf method on the most common browser that exists, unfortunately. That makes a really, really big difference because you can call this in your application startup, you can call this thousands of times easily. Granted, if you can call it fewer times, that's good, but sometimes you can't, and that actually makes a very, very big difference in practice. But again, the takeaway here is build the abstractions that you want and let the compiler take care of the rest. You'll come out much further ahead because it's like doing algorithmic optimizations as opposed to worrying about little peephole optimizations. Optimize your architecture and don't worry quite so much about the low-level details. You can always come back and peephole optimize if you absolutely have to, but when you've got a compiler in the mix, you don't typically have to as much. Okay. So finally, if I run over in time, I have no idea what time it is anymore. Okay, thank you. This is something, again, that there are other presentations that talk about this in more detail, but I want to bring it up briefly, so early on, I think most people here probably understand this already, but early on, the question we had to field 100,000 times was, how big is the GWT library? The answer is that there is no GWT library, so it's unanswerable. The GWT library is as big as your application needs it to be. That's a really, really important property if you want to be able to evolve a framework and bring in third-party libraries. So I believe in this morning's talk with Josh Block, someone was asking, what do I do if I've got to convert a 500,000 line, 500,000 line Java application to run on the web? And he said, well, somebody did this study and it was a Microsoft Office and said the average user, I'm not sure how they measured this, but I assume that they had a reasonable way of doing it, was using about 5% of the functionality in the system. That is, I assume that is roughly on an actual binary code level. So most of the code most users didn't actually need. Turns out there's a whole lot of code in Office that no one ever exercises. Same thing's true in web applications, easily, if not more so. So if I'm bringing in a library that's got all kinds of crazy functionality into it, and I only use one small part of it, I should really only pay for that one small part. And that should be true really, really deeply. And you've probably heard this before, but the GWT compiler, one of the things you also get out of having a compiler and having a static type system, is that you can really, really aggressively dead strip your code. Throw away everything you don't need as deeply as you possibly can. So the compiler is sitting there iterating over this process where it optimizes things, inlines them out, throws away functions that are not used, throws away classes that are not used, devirtualizes methods, et cetera, so that at the end of the day, all you have is the tightest piece of JavaScript you could possibly need. So it's an optimization issue because that does affect code size, which does actually matter. I know I went to great lengths to make the point that it doesn't matter initially, only to make the point that it's not as important as you think it is, but it's still quite important, especially when you start to get into, if I'm pulling from 5 or 6 different libraries, I've got a few 100,000 lines of source code, I'm using 5% of it, it really ought not download all that stuff. That's typically not been true in the JavaScript world. The best you've been able to get is sort of very coarse-grained inclusion, one sort of module at a time or whatever, sort of error-prone and manual. And then usually ends up introducing something of a small compile process. I know Dojo has a compiler now that does some sort of trivial module inclusion and pre-processing. But essentially, you really want that to happen on a really fine-grained level. And that's what we try really, really hard to do. So takeaway from that is please use arbitrary amounts of library code with impunity, because if you're not using it, you won't pay for it. So if you want to hoist one method out of one class and a gigantic library, feel free. Don't worry about the performance implications of that. So we're running low on time, and that's actually about all I have in broad terms. What can I answer? Any questions from anyone? Sir? Oh, you first, and then you. Oh, good. A0. That part I wasn't sure about. I just wanted a really old number. But thank you. Okay. Wow, you have a good memory. Or you just looked it up. Okay. Yeah. Yes, sir.
Joe, we actually have
Oh,
about
sorry.
4 minutes, so we can take a couple of questions.
Okay, thanks.
Yeah, so this is more about you want to reduce the number of calls you're doing, but if you can do some prefetch calls while the user's doing nothing, then that cuts that down. So obviously, if you can think
Right.
about the natural progression of going ahead and preload the next page instead of waiting until they actually click next.
Yes, absolutely. That's a point I really should have made. One thing I want to add to that is that yes, if you have, let's say if I've got someone paging, the typical use case is someone like say paging through a data table. It's almost a canonical use case where it would be great if you can prefetch the next page while they're on the current one. Slideshow application is another very good example of that, where it's not exactly an RPC, but you ask for the next image early so that it pops up quickly. One thing to watch out for in that is be careful how much processing you do on the RPC that's coming back. If I ask for a big chunk of data, let's say it's going into a data table to use that example, I ask for it speculatively. The most important thing there is to make sure that you don't really process it if that has any chance of being expensive, because then what can happen is, because again we're back in a single-threaded UI, you can end up hanging up the browser for a second in a way that actually affects user interaction. So it's still the right thing to do. Just be careful about how much processing you do especially on things that are speculative the user's not aware of. Because the user didn't perform that action. If the browser or the application slows down as a result of making that request they didn't ask for, then you can end up in negative perception territory. But yes, it's an excellent approach. Anyone else? Bueller? Yes, sir. Oh, I forgot. I keep forgetting the microphone thing. The recordings don't work very well without them.
Hi, I was just wondering if you have any tips. I've seen instances where if you have a really complex object that's serializable that's coming over from an RPC call, that if it's big enough, as you mentioned, it'll hang the browser's thread while that gets parsed. Do you have
Right.
any tips on how to break up that parsing to allow events to get processed, or do you just have to do multiple RPC calls to get everything over, which also kind of sucks?
Right, that does kind of suck. So currently, you would have to make multiple RPC requests. I may have to ask Bob or one of the other guys about this, but there has been a proposal to make the RPC response parser deal with those cases where you have very large responses by automatically using incremental command, thank you. I don't know why I can't remember this class name. Use the incremental command automatically to automatically allow the browser to breathe. Basically, if a parse takes more than 20 milliseconds or 50 milliseconds or something, just give it a little chance to breathe. Which thankfully it's a perfect time to do that, right? Because you're already in an asynchronous interface. So the fact that it's taking a little longer is largely invisible to the application. I think that's something we're going to need to do. We originally tried to tell people not to send down so much data, but that's really not realistic for some use cases. So currently multiple RPCs. Subsequently, we need to let it breathe, which is definitely on the table.